Hello, ladies and gentlemen. Today we're going to be talking about completing the square. So basically, before we were talking about how to find the roots of a quadratic function. And the way we were doing that was that we were setting our equation equal to 0, and then we were factoring and then solving by setting each of the factors equal to 0 using the zero product property, okay? Well, not every quadratic equation is going to factor, so we have to come up with some other ways in order to find the roots of these quadratic functions that don't factor. And the way that we're going to do that today is by completing the square, okay? Now, completing the square is a process that we're going to come back to a couple times because it can serve a couple different functions for us, all right? But in this instance, we're going to be using it specifically to find the roots of different quadratic functions, okay? So completing the square is a process where basically we're going to turn our quadratic into a square binomial, okay? And you might say, well, I don't know what that means, Mr. Guy, but here's kind of the process we're going to follow, and you're going to kind of see how we're going to do that, okay? So first of all, the first term of our quadratic should have a leading coefficient of 1. If it does not, we're going to go ahead and we're going to divide by that number, or basically clear out that denominator to make it go away so that we have a leading coefficient of 1, okay? We're going to also set these equations equal to 0 because, again, we're finding roots, so they're going to be set equal to 0, okay? We're then going to take our constant and we're going to move it onto this other side of the equation, okay? So whether that's the left or the right side, we're going to get it out of the way, make it go to the other side. We're then going to create a new constant, which is going to be our b term divided by 2 squared. And the whole reason why we're doing that is so we can create a perfect square trinomial. If you don't remember what a perfect square trinomial is, it is one of our factor patterns that we had from before. Okay, perfect square trinomial is one of our factor patterns. Specifically, it's the factor pattern that says if I have x squared, okay, let's draw this actually. If I have x squared, okay, and then I have 2ax, and then I have plus a squared, okay? So anything that follows this pattern, I can factor that and have it actually just become x plus a squared. So what we're trying to do is we're trying to force our equation to look like this. Okay, we're forcing it to look like this. And the way we're doing that is we're going to take that b term, which would kind of be this 2a, divide it by 2 and square it, and that's going to become this number right here. Okay, and that way we set up and we make it look like an x squared plus 2ax plus a squared, because then we know what it will factor to. And that will allow us to then go ahead and solve for the roots, okay? So after we go ahead and we factor it, we're then, the very last thing, we're going to extract square roots, meaning we're going to square root both sides of our equation. All right, Mr. Guy, you walked me through the steps. I'm still very confused what's going on. Here's what this process is going to look like. Let's look at our first example here, okay, number 1. So the first thing we're going to do is we're going to set this equation equal to 0 because we're trying to find the roots, and the roots occur when y is 0. The second thing that we're going to do to this equation is we're going to move the constant term to the other side. Okay, that's kind of the first step I listed up here was, hey, well, I said make sure your leading coefficient's 1. We have that. But then I said, hey, move that constant term to the other side of the equation. That's what we're going to do. We're going to add 5 to both sides to move that constant term over. So my new equation is going to be 5 equals x squared plus 4x. Now what we're going to do is we're going to do this step 3, which is take this term here, divide it by 2, and square it. So I always like to kind of call this your side work. You're going to kind of do this off to the side, so I'll make a little squiggly box over here. We're going to take this 4, we're going to divide it by 2, and we're going to square that number. So we're going to do 4 divided by 2, and then we're going to go ahead and we're going to square that number. Well, 4 divided by 2 is 2, and 2 squared would equal 4. So that's going to be the number that I'm going to add on to this side of the equation. So I'm going to go ahead and I'm going to add 4 over here. Well, if I do it to one side of my equation, I need to also do it to the other side. So I'll add 4 over here as well. And so I'm going to get that 9 equals x squared plus 4x plus 4. If I did this correctly, my quadratic that shows up on the right side of my equation should be this perfect square trinomial pattern right here. It should follow the pattern of x squared plus 2ax plus a squared. And in fact, a, you're actually going to know what it is because it's going to be whatever the inside of this equal. So 4 divided by 2 equal 2, that's actually going to be your a value. Whatever that was divided by 2, that will be your a value. That's kind of important to know because it's going to let us factor it very, very easily over here, okay? Because now I know that this over here is going to factor into x plus 2 squared. All right? From here, I can now use what's called extracting square roots to solve for what this equation would equal, for what x would equal here. The way I do that is I square root both sides of my equation. Now, I need to be careful when I do this. A lot of times we talk about square rooting a number, we're only ever talking about the primary root. In this instance, because it's something squared equals that number and we're square rooting both sides, we're actually going to need the primary and the secondary root. If you saw last week when we did factoring, a lot of times you had two answers, and this is kind of where those two answers are going to come from in this process. So I'm going to say that 3 equals x plus 2, because again, the square root of 9 is 3. The square root over here is going to cancel out with this x squared, so it's going to be x plus 2. And then I also need to say that negative 3 equals x plus 2. Again, I'm getting that because I need the primary root, 3, and the secondary root, negative 3. Negative 3 times negative 3 also equals 9, so I need to include it as one of my answers. I then go ahead and I solve these two equations. And over here, I'm going to get that x equals 1. And over here, I'm going to get that x equals negative 5. So my roots would be 1, 0. And negative 5, 0. Now, some of you might have noticed that this one actually can be factored, right? In the beginning, you might have been like, I can factor that one. It's x plus 5 and x minus 1. And if you went through and you solved it, you should get these same answers here. This process will work for any quadratic, which is what's nice about it, okay? Whether you have a factorable quadratic that is going to give you these nice integer roots, or if you have a quadratic that's not factorable, that's going to give you some of these grosser roots, maybe some irrational roots that we're going to see as we do this process. Okay, it's going to work no matter what. All right, so this one was factorable, so we got some nicer answers, but we're going to see that sometimes that's not the case, and we're not going to get as nice answers because this will work for any kind of quadratic, okay, completing the square. Let's do one more together before I have you guys go off and try two on your own. Sorry about the little bit of an edit cut here. I had to change this problem a little bit to better meet our needs. Okay, so we're going to go ahead and we're going to do the same process. So the first thing we're going to do, we're going to set this equal to 0. So 0 equals x squared minus 2x minus 6. Okay, then we're going to go ahead and we're going to move that constant term over to the other side. So we're going to say, hey, get out of our house. We don't like you. We want you to go over here so we can go ahead and we can solve. So we're going to get 6 equals x squared minus 2x. And now comes the part where we're going to go ahead and we're going to do a little bit of side work. So I'm going to go ahead, draw my little squiggly thing over here where I'm going to do my side work. I'm going to take this b value. In this case, it is negative 2. I'm going to divide it by 2, and then I'm going to square that number. So negative 2 divided by 2 is negative 1. If I go ahead and I do negative 1 squared, that's going to equal 1. Again, why am I doing this? What's the point of this? This number is what I'm going to be adding to both sides of my equation. And the reason why I'm going to be adding that to both sides of my equation is that's going to create this factor pattern right here. The x squared plus 2ax plus a. And that way I know how to factor it because I've created this perfect square trinomial. So I'm going to have 7 equals x squared minus 2x plus 1, and now I know exactly what it's going to factor to. It's going to be that factor pattern. In this case, I can see the a value. It's right here. It's whatever, when you divide it by 2, whatever you got, that's going to be your a value. So this is going to factor to x minus 1 squared. Now I can finish the process by doing what we call extracting square roots. I'm going to square root from both sides. And as you can see, the square root of 7 is not a nice number. 7 is not a perfect square. This is actually going to be an irrational number. And so what we're going to do is we're going to say, I'm going to keep writing over here a little bit, okay? We're going to say, hey, positive the square root of 7x is going to equal x minus 1. And we'll go ahead and we'll solve that by adding 1 to both sides. And so our answer, this is going to be a weird looking answer, but it's actually what our answer is. It's going to be 1 plus the square root of 7. We're also going to then have to do this for the negative square root of 7. Okay, so the negative square root of 7 also has to equal x minus 1. We'll add 1 to both sides. And again, we're going to kind of get a little bit of another weird answer. 1 minus the square root of 7 is going to equal x. And that's going to be our two roots that we have. If I wanted to write these out as coordinates, you could. This is actually a number, right? It's a way to show a number exactly where it is. I could estimate the decimal here, but again, I'd be rounding. Okay, but it's going to be this kind of ugly answer of 1 plus the square root of 7, comma 0. That's my one root. And then 1 minus the square root of 7, comma 0 would be my other root. Okay, so just a quick review before you try some on your own. You want to make sure your leading coefficient is 1. I've only given you problems where they equal 1. You're not going to have to deal with that till a little bit later. We'll look at more like that. Okay, even if you had that, all you have to do is clear out your denominator. So either multiply by something to make the fraction go away, or if it's like a 2 or a 3 or 4, divide by that number and make it go away over there. Then your constant term, you're going to move over to the other side of the equation, whether that's moving it to the right, as in this case you'll do, or if it's moving to the left, just basically get it away from your x squared. You're then going to take that b value, divide it by 2, and square it, and that's going to give you the number you want to add to both sides of your equation. The reason being you're trying to create that factor pattern, the perfect square trinomial, x squared plus 2ax plus a squared, okay? Once you've created that factor pattern, you know what it'll factor into. It's always going to be x minus that a value you found over here, or plus it, whatever that value is, squared. Then you square root both sides, and you should end up with two separate equations, the positive and the negative, what you're square rooting, to solve to figure out what your answer is going to be. All right? I'm going to leave you all these next two problems, okay? So I'm going to leave you number 3 and number 4 here. I want you to go ahead and I want you to try these two and see what you get. All right, let's quickly run through these two. Hopefully you tried them on your own. Maybe you're kind of getting a sneak peek to make sure you're doing the right thing. But here's kind of how this should look, all right? We're going to set this equal to 0. I added 12 to both sides. I then went ahead over here and did my side work and got 9 is the number I'm going to add to both sides. That makes this a perfect square trinomial. So I know it's going to factor in x minus 3 squared. How do I know that? Because whatever this number is what this is going to factor into. I then went ahead and square root of both sides. 21, not a perfect square, so I just leave it as a square root of 21. So x minus 3 equals square root of 21. X minus 3 equals negative square root of 21. Remember, we need both that primary and secondary root when we solve that, okay? We then went ahead and I added 3 to both sides. I got 3 plus the square root of 21 and 3 minus square root of 21 when I solved those. And so those will be my two roots. 3 plus square root of 21, 0, and 3 minus square root of 21, 0. Remember, these are coordinates that I'm listing. That's different than the interval notation. I know it looks almost exactly the same. One is like, hey, here's the stretch of numbers. This is just a single point that we're pointing out. Why those notations look so similar, I don't know. You have to be angry at the math people for doing that, okay? Number 4 over here, we set this equal to 0. We'll go ahead and add 32 to both sides. And then do the same thing. We're going to go ahead and take our b value, divide it by 2, and square it. We get x squared plus 4x plus 4 equals 36. Square root both sides. 36 is a perfect square, so I get a little bit nicer number here. Negative 6 and 6 is what it'll equal. And when I subtract 2, I'm going to get that x is negative 8 and x is 4. So 8, 0, and 4, 0 are my roots. That's the process for completing the square. It's one of those things that looks really, really gross. It looks really complicated, but it is a set process that you do every time, and it's the same process, okay? So it doesn't matter what kind of quadratic you're looking at. It doesn't matter what you're dealing with. Follow that process, and you will find the roots of your quadratic. Thank you all for watching.